Hi and welcome. So this is a run through all in one lesson on coordinate geometry, coordinate geometry IGCSE. So I'll give you a run through of all the components of the topic that you should expect in the video, so that you can seek out the ones that you're interested in. But if you want everything, so we'll just go down to it. Right, so the topic is coordinate geometry. Alright, so expect to learn about one, the Cartesian plane. Just a quick rundown what it is all about, and then from there expect to learn about coordinates. What are coordinates? What do they represent, and what they are not? Then you are going to learn about a line and also a line segment. And then from there, you are going to learn about an equation of a straight line. And after that, you're going to learn about parallel lines. Then perpendicular lines. Forgive my horrible handwriting. And then from there, we are going to talk about the shortest distance from a point to a line. And then from there, that is all as far as the straight line is, the coordinate geometry is concerned. So those are the 7 things we are going to learn about now. So let's begin. The first thing we're going to discuss, so the first thing we're going to start talking about is the Cartesian plane. So what is the Cartesian plane? So the Cartesian plane is simply the XY plane. The XY plane, right? All other planes that can be discussed in math are basically built on these ones, on the XY plane. Now, what do I mean by other planes? Sometimes you can draw a graph in which you are comparing maybe speed and time, where time is horizontal and speed is vertical. That's a plane too, but everything from there is derived from the XY plane that we are looking at today, right? So what does it look like? Right, so pretty much you have the vertical axis and the horizontal axis, and the coordinates, something that we'll be discussing about very shortly, are defined on the XY plane or the Cartesian plane. So this one is the y-axis, this one is the x-axis. Now, every line has an equation. So the equation of the x-axis is actually y equal to 0, and the equation of the y-axis is actually x equal to 0. You will understand that shortly. Right, so here you have the origin. This is off for origin, but sometimes you can treat it as 0, which simply means this very point. So which is at this point both x and y are 0 here. Right, and then once you draw the xy plane, you have what are called quadrants. So here you have this quadrant 1. So when you hear someone talk about quadrants, that's what they are referring to. So this is quadrant 1, and in quadrant 1, x is positive and y is also positive, which means any point on this quadrant, the value of x, which is this one, and the value of y, which is this one, are both positive. Right, now next you have quadrant 2, which is this one. So when you talking about the quadrants, you go anti-clockwise. So this is quadrant 2, and in quadrant 2, x is negative and y is what? Is positive. So simple means that if there is a point, for example this one, the x value will be negative because it is now to the left of 0, but the y value are still positive. Then here you have quadrant 3 that you can label simply Q3, and you can guess it right now that x is negative and y is also negative. And then finally we have what? Q4, which is quadrant 4, and in quadrant 4 we have x positive and y is negative. So that's the xy plane in simple terms, xy plane and its quadrants. So we have not spoken more about or in detail about the points. That's just a depiction of the xy plane. Now let's move on and start talking about what are called coordinates. Right. So there are some things that I will explain, and as I explain them, just make sure that you get it as quick as possible and in the simplest possible terms, because those things are just as simple as I'll be putting them. Okay, right. So again, we have discussed the Cartesian plane in the previous section. So here we are now. We want to talk about points now. So with the x-axis. So first of all, we will say coordinates define or locate, to be specific, a point. So coordinates define or locate a point. The coordinates of a point are in the form of an ordered pair, and this ordered pair is x, y. Some people just put a comma here, and me, I prefer to put a semicolon. I don't know why, but it works for me. Right, and these brackets are not box brackets, they are regular parentheses. Right, so that's what coordinates are. Now someone will then ask, what is a point? So this definition is important. A point marks the intersection of two lines, a line and a curve, or two curves. So pretty much a point marks an intersection of two graphs, right? So which means if we're going to talk about coordinates here, we must have points, and for us to have points, we must have lines or curves or whatever, but we're going to begin with lines. So let's define some lines on the Cartesian plane. Now, we are going to talk about vertical and horizontal lines for now. So what you need to understand is all horizontal lines have an equation y equals to a, where a is the value of y where the y-axis meets the what? The line. Right. In the same manner, all vertical lines have the equation x equals to, say, b. Now, b can be any number just as much as a here can be any number. Right, now let's put this into perspective. So let's label our axis here. So our axis here, this is 1, this is 2, this is 3, this is 4, and then down below here we have -1, -2, -3, -4, and then here we have 1, 2, 3. So these are positive values. 5, -1, -2, -3, -4, -5. Good. Right. So we just say that all lines that are horizontal, they have an equation y equals to a. Now, when I'm drawing a horizontal line, you should acknowledge that automatically that line will intersect the y-axis. Like for example, this line, watch my red lines. So this is a horizontal line, and this is another horizontal line. And then this is another horizontal line. And for fun purposes, let's just draw another horizontal line here. We are allowed to do that. Right. So all these lines and another line which is horizontal that I did not need to draw, and all of you can see, is this line, the x-axis. The x-axis is also horizontal, which means it has an equation in the form y equal to a. And if you check our first segment, I told you that this is the equation y equal to 0. So now let's explain this. So if you look at this line, it casts the y-axis at 1. So it means its equation is simply y equals to 1. So automatically this is the line y equals to 2. And this is the line y equals to -1.5 because it's here. And then this is the line y equals to -3, which is very straightforward. I guess we see that. So every line that is horizontal, it casts the y-axis. So the point at which it casts the y-axis, that's the value which defines that line. Alright, these are negative. Okay, so in the same manner, we can have vertical lines now. So a vertical line then will run like this. So this is a vertical line. This is another vertical line. and this is another vertical line. Right. Now, each of these vertical lines, they cut the x-axis. So the question is, where do they cut the x-axis? That's what we're looking for. Right. So now the first one, which is this one, we can see that it cuts the x-axis at -4. So it means this is the line x equal to -4. That is its equation. And this is the line x equals to -2. And then this is the line x equals to 2. And then this is the line x equals to 4. In that way. Now, this, look, if you look at my diagram, this is -2, this is -1, and this is 0. So which means the y-axis actually cuts the x-axis at point 0. That's why its equation is x equals to 0. And then in the same way, the x-axis cuts the y-axis between -1 and 1. Between -1 and 1. So that's why its equation is y equal to 0. So now something interesting just happened after I completed drawing the blue lines. You can see now that my blue lines meet my red lines. So which means my horizontal lines meet my vertical lines. And if you remember very well, I say a point marks the intersection of two lines, and the coordinates locate a point. Now, so it means this is a point. It means this is a point. It means this is a point. It means this is a point, and this is a point. So let's label these points. This is point A. Let's just say this is point B. This is point C. This is point D. This is point E. Oh, I didn't forget any point. This is point A, like that. So we can now locate the coordinates of these points as in the form x, y. So can we do that? What are the coordinates of point A? So if you look at point A, which is this one, it is the intersection of the line x equal to -4 and the line y is equal to 2. So which means the x coordinate is -4 and the y coordinate is 2. So the point A is -4, 2. And we can do that with another point, which is point B. We can see that at x, B is 2. And for y, you should be pleased with yourself that you've already found the value for me for y, and it is 1. Right. C is the point. Yes, you guessed it right. For x, it is 2. For x, it is 2. And for y, this kind of points harasses a lot of you, but I believe I've explained it well enough for you to understand. It's on the x-axis, and on the x-axis, y is 0. So that is the point 2, 0. And then from there, our point D is on the y-axis. So x is 0. And y is the line y is equal to -5. So, sorry, -1.5. So D is the point -1.5. Now, when you're writing D, you can write it in different ways. You can write it as D is 0, -1.5. You can write it as D is 0, -3/2. All these are acceptable ways of representing that point. And then let's talk about point E. So point E is the intersection of this line, which is x equal to -2. So it is -2. And the point -3. So E is -2, -3. Right. So now we can actually assign coordinates to the point. the thing is, here this was done for illustration purposes, but on a real Cartesian plane, in your everyday operations, you will not need to draw these lines. You can basically trace the line and see it without necessarily drawing it in blue or in red. Once you get accustomed to it, you just know that the horizontal line is y equal to something, a vertical line is x equal to something, and specifically the x-axis is y equal to 0 and the y-axis is x equal to 0. So I believe that part is very helpful for us. Now, what if a question comes and you are tasked with drawing or marking the points? Someone say someone asks you to mark the point, mark the points. So these are the points you want to mark. Say, let's say F, and F is 5, 2, and point G is negative 3, 4. Right. So what you do is you just say, okay, if F is 5, 2, it means the value of X is 5 and the value of Y is what? Is 2. So it basically means I am looking for the point where the line X equal to 5 meets the line Y equal to 2. So X equal to 5, that's my line X equal to 5. All this line up and down, that's my line X equal to 5. And Y equal to 2, I already have it on the board. There is my line Y equal to 2. So if I trace this line, they meet here. So that's my point F. And then the next one is negative 3, 4. So X is negative 3. That's the line negative 3. X equal to negative 3. And 4, Y is equal to 4. This is the line Y equals to 4. So where does this line and this one meet? If you trace them, you find that they meet here. So you mark that as your G. Right. So I believe with this, now you can locate a point, you can label a point using given coordinates. So can we move on now to the next item? Alright, so next we are going to talk about a line. We are going to talk about a line and the line segment and then some properties. Alright, so for references, let's just draw our Cartesian plane. That's one thing that we'll be talking about like throughout this. We can't avoid it. I want black. There we are. So I'll just use simplified and localized points, and then you can extrapolate that to different expanded lines. The concept, the working theory, the working operations are the same. Right, so I'll label it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. All right, so a line is simply not simply, but we'll say simply for the purposes of working it out. So a line is simply a trace of an infinite number of points that are defined by a unique equation. That's what a straight line is. Okay, so but in everyday talk, we just say a straight line is just what you draw when you pick up a ruler and a very sharp pencil, and then you go, right? But a line is, by geometric definitions, is continuous trace of points that follow a certain route. Each line is unique. Now, today we are going to be focusing, or for now, we are going to be focusing on a line segment. Now, a line segment is a finite part of a line. So a segment has a beginning and an end that we can see. Now, a line continues both ends indefinitely. It runs just through space everywhere. That's a line. But a line segment starts from somewhere, ends from somewhere. So everything that we draw in our books every day, that's a line segment. But a line, by definition, was indefinite. Now, so I'm going to draw two lines to begin our discussion here. These are the two lines that we're going to be referencing. Right, so allow me to draw this line like this. So we'll call this line number 1. Right, I will draw another line, this one. Yeah. Alright, sorry about that. Now that we have defined a line segment and we have drawn some line segments here, we are going to look at 3 properties of a line segment that I want us to work on. Right, so the properties of a line segment that you should be able to compute the following. I'm underlining now, and by way of underlining, I just drew a line segment. Right, so the properties that we will look at is, we have the midpoint, we have gradient, and then we have the length. So the midpoint simply finds the halfway point from one end of the line to the other. The gradient is looking at the degree of slope of the line. As you can see, my lines here. When I'm talking about gradient, the property that I'm referring to is, I can describe it this way. If you are looking at line 1 and line 2, and you were asked to start from the lower end of line 1 or line 2 and run without stopping up the line, which line would you prefer to run along? So you say, I would prefer to run along line 1 because it is less steep. So now when you say, what you are looking at, that makes you choose line 1. That's the gradient. So that is the degree of slope. And you can see that the gradient of line 2 is higher in magnitude than the gradient of line 1. So that's what gradient is, a degree of slope. Now, so how do you find the midpoint? So, given 2 points, let's say those points are A, and their coordinates are A, B, and then the other point is B, and their coordinates are C, D. Right, how to find the midpoint? The midpoint of A, B, which is m, is simply m has coordinates a plus c over 2, then b plus d over 2. So you add the x coordinates, divide by 2. That gives you the x coordinate of the midpoint. Then you add the y coordinates, divide by 2. That gives you the y coordinate of the midpoint. Now, what about the gradient? So the gradient of AB is simply equal to the change in y over the change in x. So when you say the change, we are talking about the change in distance. So in this case, which means the gradient, I'll write it short. Gradient of AB, I'll just write grad AB. So grad AB is simply d minus b over c minus a. So look here, you are subtracting the y's. That gives you the numerator, and then the x's give you the denominator. That's how you find the gradient. Now, you can say b minus d over a minus c. It works. Once you start with d, make sure in the denominator you start with c, which is, if you are starting with the x coordinate of the second point, if you are starting with the y coordinate of the second point, you also start with the x coordinate of the second point. Be consistent, because that affects the sign of the gradient. If you just take it arbitrarily or randomly, you might end up getting the wrong sign. Mathematically, the magnitude will be the same, but the sign will be wrong. Now, a gradient of minus 2 is not the same as a gradient of plus 2, so be careful. Right. Thirdly, the magnitude. So we have done this in vectors. It's the same thing. Basically, vectors are dependent or best described using lines. So the gradient in some sort defines the direction of a vector, and the magnitude. We've done the magnitude of vectors. So magnitude, or which is what you can call the length of AB. So the length of AB will simply be equal to the square root of C minus A all squared plus D minus B all squared. Right. So that's your midpoint, your gradient, and the length of a line segment. So for now, so it means for these lines that we just drew here, for line 1, okay, let's go to the next page. Right, let's look at our lines. Line 1, the end points of line 1, and we have line 2. Let's go back to our diagram. So line 1 is negative 2, because it starts here. This is negative 2, 4, and then it ends at 4, 1. So line 1 is negative 2, 4, 4, 1. So line 1 starts at negative 2, 4, and it ends at 4, 1. And then line 2 starts at negative 2, 2, and ends at 2, 4, if I'm not mistaken. Let's just cross-check. Right, so those are the coordinates of our points. So let's work it out. So let's start with line 1. So this is just a demonstration. So line 1, start with what? With the midpoint. So the midpoint of line 1, which is M, usually is denoted by the letter M. So it will be negative 2 plus 4 all over 2, and then 4 plus 1 all over 2, which gives us M has coordinates 1, 2.5 or 2.5. And then the gradient of m is equal to of line 1 will be so we start with the y's. So I'll start with the points, the first point. So that will be 4 minus 1 over negative 2 minus 4. So this will give you 3 over negative 6, which gives us what? Negative half. So in your final answer, the minus sign should never be below the division line. It can be on in line with the division line or above the division line. Finally, the length, which we can call L, so it will be square root of, so separate the x's square, so that will be minus 2 minus 4 all squared plus 4 minus 1 all squared. So this will be the square root of negative 6 all squared plus 5 squared, which is square root of 36 plus 25, which is square root of 61. So I will leave it here in set form or that way, because you can always evaluate it to 3 significant figures or as a decimal, that is 7 point something. Right, so we go to line 2 now. So line 2, we start with the midpoint. So m will be negative 2 plus 2. So negative 2 plus 2 all over 2, and then semicolon 2 plus 4 all over 2. So this gives us negative 2 plus 2 is 0. So 0 over 2 is 0. So that will give us 0, 2. Right, and then the gradient. So change in y. So we separated the y's. I'll start with the second point now. So I'll say the y's will be 4 minus 2 over. Now I'm separating the x's, which will be 2 minus 2. 2 minus 2. So this will give us 2 over 4, which is half. Now it's coincidental that my gradients, one of them is negative half, the other one is half, but I'm suspecting something is wrong here because my slope of the lines cannot give me such gradients. My lines are not sloping the same way. Let me check. Definitely not. I just noticed that my working is showing some inconsistency, and I think I have seen the problem. The coordinates of line 2 are negative 2, negative 2, not negative 2, 2. So let's just correct that one. So this is negative 2, not 2. So that will make this 1. That will make this 1. And then the gradient, I'm separating the y's. So the y is also must be 4 minus 2. Sorry about that. Right, so that's 4 minus 2, and this should give us 6 over 4, which is 3 over 2, which is 1.5. So that shows us that line 2 is more steeper than line 1. Okay, so now that is out of the way, we can proceed to the next item. So we have dealt with the line segment and the 3 properties, which are mainly the gradient, the midpoint, and the length. So you see how you use the end points in all these 3 properties. We use the end points. You just plug into the different formulae. Right, now let's look at something else now. Parallel lines. So we have parallel lines. The only thing that you need to know about parallel lines is they have equal gradients. So parallel lines have equal gradients. So how do you use this information? So let me say I give you two lines here. I give you line 1, and then I give you line 2. So these are parallel lines. If I tell you that these lines are parallel, like this. If I tell you that the gradient of line 1, so this is line 1, this is line 2. So if I tell you that the gradient is 2, 4, 6, 8. If I tell you that the gradient is 0.25 here, now, and I tell you that here the gradient is x, so you automatically know that x equals to 0.25. That's all. So once I tell you that two lines are parallel, and then I tell you the gradient of one of them, I've automatically told you the gradient of both, because as long as they are parallel, their gradients are the same. It's a simple concept, really. Gradient is about slope. So if they are parallel, then their degree of slope is basically the same. Now, besides parallel lines, we have what are called perpendicular lines. We have what are called perpendicular lines. So what are perpendicular lines? They are different from parallel lines. Perpendicular lines are lines that meet at 90 degrees. So also they share a property as far as gradient is concerned. So pay attention. So perpendicular lines, so they meet. This is the definition. So they meet at what? At right angles. That is, they meet at 90 degrees. Okay. Now, what should we know about their gradients? So the product of their gradients is always -1. So once someone tells you that two lines are perpendicular, then know that the product of their gradients is -1. So let's look at it here. I can draw this line and draw this line. So these two lines are perpendicular. This line is perpendicular to this one. So let's say here the gradient of this one is G1, the gradient of this one is G2. So what it simply means is G1, which is gradient 1 times gradient 2, is equal to -1. So that's all that you need to know about gradients of straight lines. That's it. So parallel lines, their gradients are equal. Perpendicular lines, their gradients give you -1. So, for example, let me draw another set of lines. Okay, let me just say L1 has a gradient of -2. Let me not use -2, of -4. Yes. Right, and is perpendicular to L2. So the question now is, what is the gradient of L2? So you use this concept. So let's work out our solution here. So let's say the gradient of L2 is G2. So we now know that -4 times G2 must give us -1. So algebraically this means -4 G2. Okay, let me just say, let's say the gradient is G, because if I say G2, this G, the 2 is just a subscript to denote that is the gradient of the line 2, but let me remove it. Right, so -4G is equal to -1. So you know what you're supposed to do here when you're solving equations. You divide both sides by -4, so that would be -4G over -4 is equal to -1 over -4. Now -4 cancels -4, so you remain with G equals 2, and then minus cancels minus, so G is equal to 1/4. So that's how you solve it. So G is equal to 1/4. So just as simple as that. Alright. Now let's look at the last thing. The shortest distance from a point to a line. So what are we talking about here when we say the shortest distance from a point to a line? So there is a point, and there is a line. Can go in any way, like anyhow. Right, so there's a point, there's a line. So let's label this P, and then let's label this L. Now, when we say the shortest distance, from this point I can walk this way. I can walk, so which means I can move from that point up to here. I can walk this way. 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 I can walk this way, this way, this way, this way, and so on. Now you will notice that when I started here, as I was moving this direction, my distance between the line and the point got shorter up to around here, and then it became longer and longer and longer and longer again. So it means the shortest distance is somewhere around here. But who can guess under what circumstances should that distance be the shortest without any other margin of error? Right. So that's what we are looking at here. So that's what we mean by the shortest distance between a point and a line. Actually, the shortest distance between a point and the line, what am I doing? Everything at my disposal. Right. So the shortest distance between a point and the line is actually the perpendicular distance. So if D, that is the distance, is perpendicular, that is, we draw a line which from the point which meets our origin line at 90 degrees. So D will be shortest. So let's put it down here. So the shortest distance is the perpendicular distance. From the point to the line. Right. So earlier on, I taught you how to find the distance between 2 points. So this point, you will be given this point, and you know that once you find this point, you can use that formula which says d is equal to square root of, then you subtract the x's square, you add to the difference of the y's. Right. So if you can get, now you can actually get it by solving, which means you first find the equation of the line D, and then solve it simultaneously with line L. You find this point, and then you find your D. But there is a quicker way I can show you that you can use this formula. So first of all, let the point P have coordinates let's just say the coordinates are PQ, right? And the equation of the line, so the equation of the line L is AX plus BY plus C equals to 0. Then D is simply equal to this. Alright, it might look scary here, but this is a very simple formula. So what has happened here, I've taken P, which is the x coordinate of our point, and substituted it here in place of x, and taken Q, which is the y coordinate, and substituted it here. Now these strokes, this line and this one, they are simply telling you that take the modulus, which means once you evaluate from A up to C, whatever you get, you can get a positive number, you can get a negative number, but just take the positive of it. If you get minus 3, treat it as 3. If you get minus 5, treat it as what? As 5. So let's say once we have simplified, you get something like minus 5 over maybe root of 47. So it means your D is equal to so it will be inside the modular sign. So you throw them away or you discard them after you have changed this sign as positive. So it means D will be 5 over square root of 47. And you should not worry a bit, even if this doesn't make sense for now. You should not worry at all, because a second video is coming. In the second video, or the follow-up video, or on this one, we'll now be talking about straight lines. So we will do everything: how to find the equation of a straight line under all the given circumstances, where you can find the equation of a straight line, and then from there we will also include this issue of finding the distance from a point, so you will see firsthand how to use this formula. So for now, I think we have covered in brief the concepts that you needed to know as an introduction to coordinate geometry. So cheers, and I hope this video was helpful. See you in the next one.